Hello, Mr. Allred from Calculus class, and we're working more examples on optimization. This problem here, it says a printer needs to make a poster that will have a total area of 200 square inches and will have 1-inch margins on the sides, a 2-inch margin on the top, and a 1.5-inch margin on the bottom. What dimensions will give the largest printed area? Okay. So what we've got to do here is we've got to work out the information that we have. So first of all, we have something here that says we have an area of 200 square inches. And there's a picture here that goes along with it. And they're labeling the poster as a width and a height. So we could write that down as the area equals width. Let's just change that a little bit. Since we're going to talk about two different areas, let's just go ahead and say that 200 square inches will be the width times the height. And what we're trying to do here is we're actually trying to maximize this area in the center. Okay, that's kind of rubbed off here. So how do we get that area in there? Well, the formulas are given here, but let's make sure we understand. So the actual area that we want to work with is across here. The regular width is W, and we have a 1-inch margin on both sides. So that's why up here you see the width of the printed area as being W minus 2. So let's put that over here. W minus 2. Okay. And then the height of the printed area, well, we'll call the height of the whole board H, but there's a 2-inch margin up top and a 1.5-inch margin at the bottom, so that's why they have H minus 3.5. So let's kind of put that in there. So what we want to do is we want to maximize this area over here. We want to find the max printed area, which means derivative. And we'll set it equal to 0. But we don't want to have a W and an H on the right hand side. So we're going to use the fact that the whole poster has an area of 200 square inches, which is W times H. So we can use this to replace either W or H. Doesn't really matter. I'm going to go with H. So let's just say we divide this out and we'll have H equals 200 over W. Now that's not very useful when we go to take derivatives, so I'll go ahead and rewrite it before I switch it over, but that's 200 W to the negative first if I bring it to the top. So let's see here. Let's change this color here and let's use blue. So we're going to replace H in our printed area with 200 W to the negative 1. So let's go ahead and make that substitution. So the printed area will be W minus 2. That hasn't changed, but then we'll have 200 W to the negative 1 minus 3.5. And the easiest thing to do here would be to FOIL this out. So if we do that, A will equal W times, let's do a little color match up here, W times 200 W to the negative 1. So those W's cancel out and just give us 200. Let's have some fun with colors. Those first, outer, negative 3.5 W, inner, looks like it'll be negative 400 W to the negative 1. And then last, we're running out of colors. So let's see if we'll just use the rainbow for fun. Whoa! And that will be negative, negative 7. positive 7. Negative 2 times negative 3.5. So that should be 2 times 3.5, which will be just 7. Okay, we'll get back to normal colors now. And we'll clean this up a little bit. A equals, looks like 207 when we combine like terms, minus 3.5W minus 400 W to the negative 1. And I'm going to double check myself real quick. I believe this is all good. So now what I need to do is take the derivative of that. So A prime, remember this is our poster area, will equal derivative of 207 is 0. Derivative of negative 3.5W will just be negative 3.5. And then using the power rule on the last part, we'll have plus 400 W to the negative 2. Now, we'll slide up a little bit here. So keep in mind we have a derivative. If we want the max, we say derivative equal to 0. So we'll set our equation equal to 0, and I'll rewrite a little bit while I go here. So negative 3.5, then I'm going to write it as plus. I'm going to change my W to the negative 2, and we'll have 400 over W squared. So now to solve that, let's just multiply both sides by W squared to get it off the bottom. And in that case, we'll have 0 equals negative 3.5 W squared plus 400. We'll bring things over to one side, be 3.5 W squared equals 400, and we'll divide by 3.5. Looks like I gotta use more paper here. So we'll divide by 3.5. We'll pull out my calculator in a minute. Maybe it'll be something good. But W squared equals 400 divided by 3.5. Ooh, not good at all. So I'll just go ahead and write the number here, 400 over 3.5, and I will take the square root. Now, of course, the square root will give me a positive and a negative, but I'm just going to go ahead with the positive since we know the width can't be negative. So square root of 400 over 3.5, and if we want to kind of round that off, it looks like that will be about 10.69 inches. So let's see what that means. So that's not a number you would guess. You would not guess that answer anywhere in this work. So let me come back up here. Now let's highlight that for now. W equals 10.69 inches. Let's come back up and see. So we did have a relationship between W and H up here. Okay. And since I rounded off, we'll just go ahead and use that, but it says H equals 200 over W, and we just decided that W was 10.69. So if we divide that out, we get 18.71 inches. So we have a width and a height there. And let's go back and make sure we answered the question here. It says, what dimensions will give the largest area? So that's the printed dimensions. So the printed, and it's pretty important that we print the right, print it the right way because we want to make sure the height and the width match up. So just to kind of put everything back together up here, H would be 18.71 inches and W would be about 10.69. And let's use the approximation there since we rounded off. All right. So once again, we had information about two different things. They both happened to be area this time. They weren't different formulas. They were just different parts both area. So it wasn't a perimeter in the area, it was both area, just two different pieces of area here. And we use both equations. The 200 equals W times H in the actual area of the printed part. And we made a substitution there because we knew about the 200. All right. Thank you.